mixtures. Mixtures are often the result of a change that occurs. A mixture represents a physical blend. So a physical blend of the substances sharing a container. The mixtures present, or the substances present in a mixture, they are chemically inert, meaning that they do not chemically react with each other. They just simply share the same container. Because of that, mixtures can be separated into individual substances using a variety of techniques. The technique that is chosen to separate the components of a mixture from each other is based on an idea of opposites or differences in their properties. So common separation techniques used at home is if you strain food items. So done cooking pasta, we tend not to eat the pasta while it's still in the water that was used to help cook it. So we use a colander and strain out the pasta, let the water flow out of it. Sorting can be a very simple separation technique. So putting away laundry, putting away dishes that are clean, items tend to have different places that you store them, so you sort them out and place them in their appropriate places. Or something similar to straining would be the idea of filtering. So if you have a coffee pot that uses the paper liner, coffee grounds stay in it, the water and flavors of the coffee pass through it, or an air filter that traps particulates from the air so that you're not breathing it. So let's take a look at some of these ideas of separation that we use in the chemistry lab. So the first one is the idea of filtering. So you have your mixture, you pour the mixture into the filter paper, components of the mixture pass through the filter paper and collect in like a beaker that's down below, and other parts of the mixture remain in the filter. So two ideas here. So number one, there is a definite difference in the particle size. So the larger particles tend to stay trapped on the filter paper, and the smaller particles pass through it. Now, the other component here that we have to think about is the solubility. So when we use the idea of filtering here in chemistry class, usually we have some sort of liquid portion to the mixture blended in with other things. Some of the particles dissolve in the water part of the mixture and pass through the filter paper along with the water. The particles that are larger and stay on the filter paper, they tend to be insoluble. Another technique that is used is a fancy word called decant or decanting. And decanting means to simply pour off the top layer. So pour off the top layer. So what tends to happen here, a difference in the properties, is number one, solubility. So what portions of the mixture are in what looks like a liquid or solution? So some things are dissolved and they stay with the liquid. And then you have other particulates that tend to be undissolved, and there's a natural layer separation, so we have a difference in density. So a lot of times the solid particulates are more dense, so they fall to the bottom of the container, and you can pour off whether it's a pure liquid or a solution and pour off the top of it. So we have a level of solubility, we have density, but we also have a phase difference. So an aqueous or liquid phase and a solid phase. So we have some properties that we take into consideration. Can we just simply pour off the top? Now we have another piece of equipment. It's called a separating funnel. So you can see the name in the diagram. And typically we use this when our mixture is comprised of different liquids or different types of solutions. So we can visually see a difference in the layers. Both look liquid to us, and there is definitely a difference in the density layer. So in the case, this uses a gravity where we open the valve, and so we open the valve, and the bottom layer, the more dense layer, flows out the bottom, and then you turn the valve off, leaving the lesser dense layer. So we use this separatory or separating funnel to successfully remove the more dense layer.